Hello there everyone, and welcome back to another video from the lecture series for the course of database design and implementation. In the previous lecture, or in the previous video, we had discussed about the different components, or we basically discussed about the different components in the entity relationship model, okay? Which the motivation behind using that particular model was to introduce simplicity in the graphical representation of our database design. Okay, so in that particular model, we learned about the different components and subcomponents that are usually associated to entities, attributes, and then relationships. Okay, we talked about the different types of entities where you can have strong or weak entities that are developed based on the concept of existence dependence. Okay, we talked about several different types of attributes. We talked about required versus optional. Okay, we discussed about simple versus composite attribute, and this was one of the more important evaluations that you have to make with respect to your attributes. We also discussed about single valued, single versus multi-valued attributes, okay, where this is going to have a significant impact on your design once you identify an attribute to be multi-valued. And then we talked about derived attribute, which needs to be evaluated for the sake of reducing data redundancy in your database design, either reducing it or keeping it in order to assist, let's say, some of the performance parameters for the implementation of your database with respect to running different queries, right? So other than that, within the relationships, the different components or subcomponents that we discussed was the fact that in an ERM, when we talk about the different types of relationship, we call it connectivity. Okay, so if somebody asks you what is the connectivity between entity 1 or entity 2 for a given relationship label, then what you are going to answer is basically what are the different relationship types. So we know that the different relationship types, we have discussed this numerous times before, is one of these three, right? Then we learned about the concept of cardinality. That is the minimum and the maximum number of association of a given entity instance with another entity, right? And we talked about relationship strength, which can be non-identifying, which is weak relationship strength, and then identifying, which is strong relationship strengths, right? We talked about relationship participation, which is along the lines of optional versus mandatory participation. We also discussed about relationship degrees, which could be unary, binary, and ternary, where ternary is a conceptual level relationship degree, and it needs to be implemented by the use of a linking attribute, or not an attribute, but a linking entity, which is also known as a bridge entity or a composite entity or an association entity. And then we talked about recursive relationships. Okay. So whenever you are coming up with your ER diagram, which basically is built on top of the ER model, right? And you represent that using crow's foot notation. Okay, and you are going to typically draw that by using the aid of tools like MySQL Workbench. For each and every entity that you have to evaluate its attributes, and then you have to evaluate the relationships that each and every entity has with different with other entities along the lines of these different subcomponents. Okay, so specifically speaking, what kind of effect these things will have on each other is guided by some of these specific subcomponents. So what I'm trying to say is, like, if you need to single out with respect to a descending order of priority, that which subcomponents matter most in each of these different categories and why should you be looking into them, this is how it goes, right? So first, the very first task with respect to your design process is to identify all the entities. Okay, so from your business rules, whatever it is that you formulate, the first task is your entities, to identify all the entities. What follows after that is identification of all the attributes in a given entity. Okay, so once you do that, so of course, when you have identified the entities, you will also have to categorize them with respect to strong and weak entities. Okay, where strong is basically the entity can exist by itself within the database environment. But if it's a weak entity, that means that that entity has to be in a relationship with another entity in order to have some meaningful existence within your database environment, right? And then you have required versus optional. And this plays a very important role with respect to determining whether the data value of that particular attribute belonging to a given entity can have null values or not. Okay. The second thing, so this will be one, and then the second thing is to identify whether that given attribute is composite. If it is simple, well, it's simple, right? There is nothing more to think about there, right? But what you have to evaluate after required versus optional is basically whether it is composite, right? Because as we learned, composite attribute can be further broken down into different components. Okay, so you will have to check for each attribute whether it is a composite attribute and whether breaking it down into its smaller components and making it more simpler will help you with respect to your query formulation. Okay, and then the third one that you have to take into account is to check if your attributes are multi-valued, because multi-valued will be broken down into other weaker entities that will be in relationship with the original entity from which this attribute is coming from. So that will also have a significant impact on the entire design itself. Okay, and then finally, the last one that you will evaluate is derived attributes, right? Whether or not you want to keep it or whether or not you would like to remove it. And as a result of that, it will have an impact on the types of query that you're going to write. Then comes relationships. Okay, then you start establishing the relationships amongst different entities. That is how the data is going to flow from one entity to another entity, and it is going to be modified and recreated. Okay, so of course, connectivity is the most important thing that you need to assess here without any kind of doubt. Cardinality is not that important. Okay, cardinality is mostly to implement constraints. Okay, so remember, in terms of the basic building blocks of any data model, we had four different components, right? We had entities, attributes, relationships, and then there was another one which was constraints, right? So here, cardinality is actually reflective of the constraints, because it is kind of establishing that what is the minimum and the maximum number of association between two different entities in a given direction of your relationship. Okay, so that is for your constraint. Strength is important thereafter, is because of course the strength is going to determine the representation of your database design as well. So it has a direct consequence on how your database design is going to look. That is whether you're going to have dashed lines versus solid lines, right? And it kind of is a representative of whether the relationship is between two strong entities or between a strong entity and a weak entity. And as a result of that, it will also have an impact on the way you're going to implement it, because coming from the concept of what a identifying relationship is, the primary key of the child entity in the relationship is going to be made up of either completely or partially using the primary key of the parent. So that has a direct implication on your implementation as well as how your design is going to be represented. Participation is also has an impact, but it is kind of related to cardinality. So you can check participation thereafter, because it will have an influence on how your database design is going to look. So it could be like something along these lines. If we are using crow's-foot notation, mandatory participation versus optional participation, right? Mandatory 1:1 versus optional 1:1. So that's why you need to check participation thereafter. And participation kind of associates with cardinality with some generality, like it being a bit more general, right? What I'm trying to say here is that here the participation will be able to specify that the cardinality is 0 to m. But if you exactly go within cardinality, then you will have to unroll 0 to m and say 0 and 6. So you see, this is cardinality is a more rigorous implementation of the participation requirement between two entities, for the relationship between two entities. Okay, degree is about making your design more robust. As long as you understand your functional requirements and you're able to clearly depict it, then you don't have to address degree as such. Okay, because as long as you know what the degrees are, it is more or less useful, right? But you don't really have to assess it unless, if you fully understand your functional requirements and you are able to map the relationship between the different entities, you don't really have to go into degrees and then talk about it. And the same goes for recursive relationship as well, right? As long as you know the concepts and you understand them and you are able to concretely map your business rules to an EER diagram, then you don't really have to go into degrees. Okay, so that kind of captures how you're going to take the concepts into your actual design, and which concepts do you need to address one by one in a structured fashion in order to generate your final EER diagram. Okay, so that takes us to the agenda of this lecture, is to address the question that can we further improve the EER design. Okay, so this is basically what we are trying to answer and learn the concepts associated to it in this particular video. Okay, and that is basically to learn about the enhanced, and in some cases it will also be known as extended entity relationship model. Okay, which is also known as EERM. So the basic idea of EERM is to introduce object-oriented concepts to database design. Okay, but only the useful parts and not the parts that complicate it overall. So do not confuse this. Do not confuse EERM with object-oriented data model. Okay, so these two are completely different. Okay, so the way it does this, the way enhanced entity relationship models introduces the concepts of OOP to database design is by what is known as attribute inheritance. Okay, so this is what we are going to be discussing in this particular video. And of course, this chapter thereafter has other topics which specifically discusses two different scenarios. One is the selection of primary keys, right? So up until this point, we know what primary keys are, right? But we have not really addressed that which attribute or which candidate key will be a good selection to become the primary key of the table. Okay, so just a quick recap, that a candidate key in a table is basically the one that follows full functional dependency. Okay, and at this point I'm expecting you know mathematically what full functional dependency means. Okay, so primary key is basically the candidate key which is selected to represent the table or uniquely identify every row from each other within that particular table. Okay, so then the question is, if you have multiple candidate keys in a particular table, then how should you formally make a selection of the primary key, right? You cannot whimsically or on an impulse say that, okay, I'm going to select this one as the primary key, right? There has to be some sort of thought process behind that selection, right? So people have, throughout the past years, many years, right? They have come up with different well-established heuristics, okay, for selection of primary keys. So we are going to just briefly go over those different heuristics, which will help us kind of make the decision in a formal way when, for any table that we have within our database design, we are trying to make a selection of the primary key. And then there are different database design scenarios, okay, different database design scenarios. Okay, so here specifically what we are going to talk about, of course your textbook has multiple different design scenarios, but what we are going to focus on is specifically preserving the historical accuracy of data, and then we're going to talk about this specific erroneous design case within database which are known as fan traps. Okay, and then we are going to discuss a bit more about recursive relationship. Okay, the last one which is there, which we are not going to revisit again, is the implementation of 1:1. So we have talked about this previously when we were discussing about implementing the different relationship types with the keys, right? So you can read your textbook about this chapter. Most of them is revisiting some of the topics that we have already covered, right? So we are not going to go again into them and talk about the same things again. Okay. So in this particular video, our goal is to just discuss about the enhanced EERM, right? And then in the second part of the video, we will talk about the selection of primary keys and then different database design scenarios. Okay. So to recap our data model processes, we had the relational model, okay? Then we learned about the entity relationship model. And now in order to further improve our database design, we are going to discuss about the enhanced entity relationship model. Okay, and this will finally give us a ERT that will be representing, or EERT that will be representative of our database schema, okay, or database conceptual design. All right. So let's talk about the motivation. Let's say design motivation for using EER. Okay. So in this particular process, think of a database scenario where, or a problem domain of inventory management. Okay, inventory management. You can have this domain, and then you can have, let's say, let's consider another different domain, problem domain of airport management. Okay, airport management or airport services, whatever you're going to call it. Okay, but you get the idea. It's mostly related to creating a data storage for the personals who are working in an airport, airplanes that are coming in and out, let's say purchase transactions of tickets, client accounts, etc., etc. Okay, and inventory management is basically product management. If you have something, let's say a website or a platform for e-commerce, right? You're selling different products, so then you have a warehouse where you kind of are storing all the products. So you want a database which kind of keeps a track of all the inventories that are in store, which aisle has which kind of inventory, which kind of product, and then the sales information of these different products, the shipping information of these different products, the reordering information of this, reordering and restocking information of this product, uh, employee information within this environment as well. So typically this will be something like if you work for organizations like, let's say, Target or Walmart or Amazon as a database manager, right? Or as an information technology specialist, right? Then you will be working on the databases regarding operations like this, okay? So in this problem domain, right? Let's say you have an entity which is represented using the relational notation of products, okay? So typically, like the go-to, you know, idea of an entity within the inventory management system is product, because that is like the central driving force of inventory management. If you don't have any products, then, well, what exactly are you managing? Then it becomes a different problem domain, right? So if you think of an entity product, right, you can have different things like ID. I'm just relaxing the writing notation of writing it as product ID, right? But whenever you are going to be writing any notation, any relational notation, or the names of any attributes, then make sure that you follow the convention, the naming convention, where you have a prefix of the entity that this attribute belongs to, okay? So you can have ID, then you can have unit number, okay? Then you have, let's say, manufacturing date, then you can have things like aisle number, aisle number, okay? Let's say quantity in hand. You can have description, description, right? And what else? Let's say you have something like properties. Okay, what are the specific properties of a product? So this is one scenario. And then another scenario, you can identify multiple entities like ground staff, Okay, never have space between the names. Okay, otherwise that is going to create like a nightmare in your SQL environment. And then ground staff will have ID and then name and then address, etc. Right? And then you can have pilots, which will also have ID, name, address, and then assignment, and then let's say license, etc. Okay, then you can have mechanics, okay, which will also have ID, name, address, and then mechanical assignment. Okay, specialization, let's say mechanical certification, and so on, right? And then you can have other similar entities, other people or other category of personnels who work within an airport. Okay, you can have. So now if you pay attention to what is happening here in this first scenario, let's say if we look at a specific attribute like the properties of different products are not going to be the same. Okay, so let's say if you have different categories of products, right? So you can have, let's say, smartphones. A product can be a smartphone. Okay, a product can be a bedding product, right? So what I'm doing right now is basically if you go to Amazon.com, right? And then you can have shop by department. And then if you go within a department, you can also have different categories. Like, so if you go into the electronics department, then you will have different categories like, let's say, phones, tablets, what do you call it? Laptops, desktops, okay? And then other stuff like PC accessories, phone accessories, and so on and so forth, right? But all of them are products. So impulsively, when you're trying to, if you have created an entity of product, then what you might realize if you go deeper into the design scenario is that each of these products may have different categories or different types of products, right? And within each of these products, there could be different specific attributes that are related to only those category of products. Okay, so that means like the specifications that are there for phones and tablets necessarily might not be the same. Okay, then the specifications that you have for laptops might not be the same. Similarly, if you have the categories of smartphone versus bedding versus, let's say, furnitures, and let's say kitchen supplies, if you look at this particular attribute, you might not have the same attributes, right? But everything else might be the same, right? They all have an ID, they will all have a unit number, they will all have a manufacturing date, they will all have an aisle number, quantity in hand, description. But the nature of how you describe the features of those products might not be the same. Okay, so to take a very specific example, all of these electronics department will have features like screen size, okay, processing, maybe. Again, it's not universally applicable because if you do accessories and phone accessories, you don't have any processors, okay. RAM, and then storage, and stuff like that. But then bedding will have bed size. Okay, if you have, let's say, bedding covers, then you're looking at thread count and things like that, right? So now, if you understand this difference, and if you try to visualize this implementation within just a single entity, what will end up happening? The first issue that you will have is you have to universally go through each and every category that you have, and later on, if there are new categories added, and then you have to identify what are the specificities of each of these different product categories. Okay, these are all entity instances of the entity product. But if you implement them in a single table, then you are slowly creeping towards the issue of structural dependency. That is the first problem. Okay. So it will end up creating structural dependency. So I hope you all understand why. Okay, because again, all of these different entities, so these products are entity instance within this single product table, right? All of them have, may or may not have, different unique categories of properties that you might need to store. Okay, because it is pretty evident that when a search operation is performed on inventory management, users are going to search using the specific filters that are applicable to that category. That is inevitable. Okay, so it will have it, right? So that is what the notion of this particular attribute is, to help you with those data transformation techniques. Okay, so then if you implement this as a single entity, then that means you have to identify the specific features of each and every entity instance within your particular table, and then you will have to add columns for them such that you can store the data value. Okay, so that means if somehow you decide that, okay, we are not going to sell anything more than smartphones, beddings, furnitures, and kitchen, then that's fine. Okay, but in the future, if a product within the same category comes out that has a feature or a property which is different from all the initial columns that you have, then you have to add new columns. Okay, and that kind of makes the whole design a bit shaky. Okay, so we are just going to say partial structural dependency, because in some ways you can avoid it as well if you make it static. Okay, the second problem are null values. Okay, and why? You should be able to answer this question. Why will there be a lot of null values? It's quite self-evident. So we are thinking that there is a single table of product. Okay, so this is your product table, and then you have some common attributes in the form of ID, unit number, manufacturer date, etc. And then after that, you have a set of attributes which are specific only to a given number of entity instances. Okay, so that means if I have, let's say, for example, thread count and bed size, then for all the products which are electronics, for the columns of thread count and bed size, we are going to have null values. So now if you kind of project that to the entire table, you're going to have a plethora of null values, many different null values. Okay, so that is the first scenario. So how do you resolve this? So that is our initial question. How do you improve this design such that you can at least address some of the challenges that you currently have? Okay, and then let's look at this other scenario. Okay, so what is happening here? Here you have different entities. So this is just the opposite perspective of this particular problem domain. The issue that we are having here, the problem here is in the opposite order. So what is happening here is that you have multiple entities which have their own specific special attributes. Okay, so like pilot has his own special attribute like license number, assignment, let's say, to the planes, the routes that they're trying to fly. mechanic certification, what kind of specializations do they hold? That will be only held by a mechanic. And ground staff will also have some kind of special attributes. I cannot think of one at this point of time, but if you can, then you can help yourself to understand. Okay, this is typically the point where I would ask you, and we will have a discussion. But anyways, what you have to pay attention to, that now there is a redundancy of the common attributes across these different tables. So the issue that is cropping up here in this particular instance is basically redundant data. So instead of null values, plagued by null values, now we are in this particular domain, we are plagued by redundant data. Okay, so now the question is, how, again, the same question, how do we improve? How to improve this? Okay, so these kind of design scenarios, or these kind of design scenario challenges, are basically addressed by enhanced entity relationship model. Okay, so this particular instance, when it is addressed by entity relationship model, this particular instance is known as specialization. Okay, so let's say when addressed by EERM. Okay, and this particular scenario, when addressed by EERM, is known as generalization. Cool. Okay, and the way it does it is by introduces, so what we will say here is EERM helps to further reduce the presence of null values and data redundancy by the database design process or processes of specialization and generalization, respectively. Okay, and it does so by introducing the concept of attribute inheritance. Okay, and the third remark is specialization is a top-down design process. So what that means is that we start with a single entity and then we break it down into smaller entities. Okay, and then generalization, of course, is a bottom-up design process. Okay, so what that means is that you start with multiple entities and then you kind of create a single generic entity out of it, okay, using all the general attributes of these different entities that are present. Okay, so these are some remarks. So let's look at some definitions before we further go into formally understanding the enhanced entity relationship model definitions. Okay, so the first definition is entity supertype. Okay, so entity supertype is basically the common or generalized entity that is created using other entities. Okay, and secondly, you have entity subtype. Okay, so entity subtype are basically the specialized entity created by breaking down a given entity. Okay, so thereafter there are a few more remarks that we have to go through. So let's say remark 2. The entity supertype stores all the common attributes of its subtypes, of its entity subtypes. Okay, and of course entity subtype will have or will store attributes that are specific to them. Okay, and it will not store anything else. So after that, remark 3, is that to use EERM, there must be different identifiable entities within the database. Okay, so that means there has to be entities. If you create a set of entity subtypes, they actually have some variation between them. Okay, you cannot just simply take each and every input of a given table's row and then start creating entities out of it. Okay, that is not what EERM is kind of telling us, right? What it is telling us that if there are input instances or entity instances that have some specific features which is special to them, right? Or you have multiple entities which has some features which are common to them. That is, there are entities which are different and you can actually differentiate between them. Then you can apply EERM. Okay, so that is the first case. And the second case that is important, that these entities, and I'm also going to add and entity instances, must have attributes that are unique to them. Okay? If an entity does not have an attribute, these differentiable entities, if they don't have attributes that are unique to them, then you cannot create entity supertypes and subtypes. Okay? So now let's look at a typical EERD. Okay, so basically a enhanced entity relationship diagram. So these were all the model aspects, and then there are a few more components of EERM, but we will discuss this once we talk about uh, this particular diagram. So we are using the example from the book where you have an employee. Okay, so I'm going to write EMP, and then it has claims. Let's say dependence. And then from here, and I will leave a small space, and then I will say give a space here, and then from there draw out 3 more. Okay, so you have pilot, you have mechanic, and then you have staff. Okay, ground staff. Okay, this covers, so there are a few empty spaces. Okay, all right, so let's fill up the blanks here and let's have some fun. So some of the things you kind of recognize here, right? Of course, you recognize the entities, you recognize the basic relationship here from ERD. What is new in this is this part here. Okay, so here, this is an example. This example that we will be talking about is for specialization. Or not specialization, this is an example of generalization from the way we are discussing it, right? Because we had pilot, mechanic, staff, and we are trying to create a super type, which is employee, that will inherit all the common attributes of these subtypes, and then these subtypes will have special attributes within them, and then we will complete the overall EERT by talking about 3 different components that completes the design process. The first one is known as basically the constraint. Okay, and then the participation. There are 2 constraints. One is the participation constraint, and then the other one is the association constraint. How is it associated to the different entities? And then there is a subtype discriminator. Okay, okay, so participation and association is basically another word for cardinality. Okay, association or cardinality. So then let's talk about what these components are first, and then we can come back to this design and make more sense of it. Okay, so first of all, let's go back to our definition board. And let's finish up this whole components process. So let's say components of EERM, which is used to basically draw an EERT. Okay. So the first components we have already discussed. So we have entity supertypes, we have entity subtypes. Okay. In addition to that, we have constraints, and constraints are of two types. One is participation, and participation are again of two types, which could be partial or complete. And then the second one is cardinality, which can again be of two types, which is disjoint and then overlap. And then the fourth component is basically the subtype discriminator. Okay, so now let's build up this concept from this. So now we have all the components, and let's talk about the concepts behind these components and then build our knowledge or understanding from this one by one. Okay, so the important thing is every subtype, so between these two, every subtype must be associated to a supertype. Has to be. It cannot exist independent of a supertype. Okay. Thereafter, the relationship is interpreted as a is a relationship. Okay, so that means a pilot or an employee is a pilot. Okay, so if you want to interpret this relationship, you're going to say an employee is a pilot, and a pilot has to be an employee within this particular domain. Okay, it cannot be something else. So that is what the first point is basically trying to say. Okay, so thereafter, implementation wise, these relations, these meaning the relationship between the subtype and the supertype, is a 1:1 relation. A 1:1 relation with identifying relationship strength. Okay, it's always strong. And as a result of that, you can kind of interpret from this that the subtype is always, the primary key of the subtype is always going to be the primary key of the supertype. Okay, all right, good. So we understand now between the dynamics between these two components. Now let's look at the constraints. All right, I thought there was a gray color somewhere. No? Okay, I'll just use green. All right, so what does partial and complete participation means? But before that, let's talk about this cardinality, disjoint and overlap. Okay, this means, disjoint means if you take subtype 1 intersect it with, let's say, subtype 2, keep on intersecting it up until, let's say, subtype I or subtype N, anything. This will give you phi or empty set. Okay, whereas if you have subtype 1 intersect, and intersect is the relational intersect operator. Okay, and I hope you remember what it does. Okay, if not, then you should revise it quickly from the relational video, relational operators video, and come back to this, okay? And then up to subtype n. This will give us some rows. Okay, so this is basically what the difference between disjoint and overlap means. Okay, complete participation means, so let's choose, what is this? Dark blue. Okay, complete participation means a subtype or a supertype must be one of the given subtypes. Okay, so that means for this particular example, all the rows which is in an employee must be either a pilot, a mechanic, or a staff. At least one. It has to be, right? Whether it is more than that is determined by cardinality after that. And partial means a supertype may or may not be one of the specified subtypes. Or let's rephrase this and say may be more than one of the specified subtypes. So in terms of representation, a partial, the disjoint and overlap is specified by using the symbols. Within the circle, it is written as D or an O. And a partial is represented by a single line segment between this circular symbol, and a complete is represented by two line segments, right? So that is the reason why we have this sign here. Within this, we are going to specify what is the cardinality, and then underneath this, we are going to specify what is the participation. And then finally, we have the subtype discriminator. Okay, let's take orange. I've never tried this. Doesn't look that good, but whatever. So subtype discriminator is a special attribute in the supertype that is used to determine which subtype a given entity instance in the supertype belongs to. Okay, how is this orange? That is what I don't understand. It looks yellow to me. I'll never understand colors. Okay, so that is what all the different components are. So now let's fill out this diagram here. So this is our supertype. So this is the supertype. These are its subtypes. So that means there has to be some attributes. So let's say pilot license, certificates, and I don't know what whose staff has. This is what I cannot figure out. Something XYZ. What will be specific to a staff that will not be in mechanic or pilot? Degree? Clearance? Something along these lines. Okay. And then here, this empty bracket that we have left out is basically going to specify the subtype discriminator. Okay, so here we can have type, where type is basically an enumeration, which could be P, M, and then ground staff, ST. Okay, something along these lines. Or you can even use numerical values if you want. The other option is you can do, let's say, 1 1, 2 2, and then 3 3. Any kind of numerical coding. Okay, but the idea is if you run a switch case statement, or if you write a procedural program where you have to run a switch case statement, this attribute is basically the different cases, and then these subtypes are basically the blocks of code where your compiler will take you. Okay, so here I have type, and then type has to be present here as well. Okay, because it is a special attribute within the supertype. And thereafter, the supertype has all the common attributes of these subtypes. So that means it will have things such as ID, name, address, etc. Okay. The other thing is any relationship that the supertype has. So for example, this will also be a inherited relationship. Inherited by whom? All its subtypes. Okay. So now the last two things that are remaining is basically the participation and the association or the cardinality, right? So let's look at the cardinality. Cardinality being, can an employee be both a pilot and a mechanic at the same time, or a mechanic and a staff at the same time, right? So you have to kind of use your intuition or your organization's policy in order to determine that. So just for the sake of this discussion, let's say it's disjoint. Okay, so that means the intersection of all the subtypes for the rows is going to return an empty set. Okay, and then given that there are three subtypes here, does an employee need to be either a pilot or a mechanic or a staff at least? Okay, it can be more than that. Or can it be something which has not been currently specified in this diagram? So that means what it is asking, that in this encoding, where 1 1 represents, let's say, a pilot, 2 2 represents a mechanic, and 3 3 represents a staff, can there be another encoding 0 0 which does not have a subtype? Okay, it does not belong to any of the subtypes because maybe it does not have any kind of special attribute, because remember, subtypes needs to have a special attribute that is specific to them. So maybe it doesn't have it, right? So if that is the case, then your participation is going to be partial. If that is not the case, then your participation is going to be complete. Okay, so that is basically the idea behind EERD's specialization and generalization. So let's look at another example. Example 2. Okay, and this time we will try to, for that particular diagram, even though we kind of did draw it out from the start knowing what we were doing, right? But we had these discussions here, okay, in this domain. So you kind of get the idea of where or how we are arriving at this notion that we have to break down our entities and create further entities that inherits the attributes from those entities, right? So let's look at another example, example 2, within the university domain. Okay, did I specify that 1:1? Yeah. Okay, I really don't like this How is this orange? For some reason, I'm just stuck on this. That's a yellow. Okay. Oh, that's how YouTubers do it, right? They will tell you like, let me know in the comments below, what do you think if this color is yellow or orange? Let's try that. I need to learn from the YouTubers. Anyways, university management. That's a good way of interaction, actually. So within the university management, let's say all we are discussing at this point of time is we have professors, okay, and then we have students. So for all the examples that we have discussed up until now, this is what we keep on saying in terms of the entities. Of course, there are other entities that are present in this particular domain. You have courses, you have buildings, you have departments and stuff like that, right? But we are going to focus on the parts from where this design can start to improve and branch out, where we apply EERM, right? So now, if we go for professors, we will also realize that let's say there are administrative assistants, there are secretaries that work for our department and they support us, right? Very crucially for all the administrative tasks that is being performed, that is keeping the department alive and going, right? So they're a very important part of the whole university domain as well, these administrative secretaries and then these executive administrators as well, right? In addition to faculties. So then if you want to store their information, then you will create something along the lines of a staff. Okay. Now professors will have certain their own designation and stuff like that, assistant professor, associate professor, full professor and stuff like that, their degrees, courses that they're teaching, assignment, anything along those lines, right? And staff will have their own allocations as well, that what is their job title, which department that they're working with, which is not really a specialized attribute for that particular entity, but something similar those lines. If they're accountants, if they have any specific accountancy degrees and stuff like that. Okay. So this is the scenario, right? So now this is what we have. But then we realize that, oh, okay, staff and professors have these common attributes of things like ID and their name, their contact address, any personal identifying information. So then we decide that, okay, we will do a attribute inheritance, and basically we will do the process of bottom-up process of generalization, and we will create what is known as employee. Because after looking at these two entities, we realize that there are a lot of common entities across them, that such that we can basically merge them together and combine them and create a super type, and then keep the specialized attributes within themselves, right? So staff is an employee, professor is an employee. Okay, so then the specialized or subtype discriminator is going to be the employee type. Then you will have, what is it, disjoint or overlap. So that means, can a administrative personnel be also a professor? Yes, right? Case in point being provost, dean, chairs, they can fall into the administrative roles, but they're also professors. And then there are department secretaries who are specifically within the staff entities, right? And now what about the participation? Is it complete or is it partial? So that means that given that I have only two subtypes right now, does an employee within the university has to belong or have to belong to one of these two subtypes, or there can be different categories which we have not specified right now. So we don't know, okay, and we will give ourselves the benefit of the doubt that maybe there are contractors, okay, who have contractual recruitment from the universities, and they can be there as well, right? But we don't know that because our design started with professor, we had staff, we don't know if that is present right now or not. So we will address that on a case-by-case basis at a later stage, okay? Okay, so that completes this side. So now we can note by looking at student and employee, we again have a set of common identifiers. So we have IDs, we have name, and we have address within student as well. So then what we can do is we can take this super type and student and then create a super type out of them, which we can call personnel, okay, which will have complete participation, because the personnel within a university either has to be the employee of the university or a student, because we have addressed the other type of employees here and we have kept this partial, right? And what about the degree? Can an employee be a student? This is a good question. Okay, so let's leave it at, okay, I need to make it a bit bigger. Okay, let's leave it at overlap for the time being. Okay, and let's say the discriminator is personnel type. Okay, if you just have two, then you can even use discriminators which is something like is an employee. So then your decoding will be 0 or 1. If you have 0, it's not an employee. If you have 1, then it's an employee. Okay, or you can use the very basic one, which is personnel type is going to be either, let's say, 1, 2, 3 for employees, and then 6, 1, 9 for student, depending on however you want to create the flags. Okay, so this is a funny thing, I think. Yeah, this goes to the next slide, and then you cannot erase them anymore. It's kind of mystery. Anyways, so this is where it stands right now. But then, if you focus on student, can there be any kind of specialization? That is, now we are looking for specialization. So we have addressed all the generalization. So we have gone through the whole design in a bottom-up process. So now we are asking ourselves, top-down, right? What has been generated by the bottom-up or generalization, you don't have to revisit them anymore because, well, the top-down is kind of there, right? But then you have to look into the subtypes or the initial entities again. Can a professor be further broken down into subtypes where the subtypes have special attributes? We know that the professors have different designation, right? You can have like assistant professor, associate professor, and then full professor, right? And then special instructors. But do they have any kind of special attributes that are associated only to them? If the answer to that question is yes, then you can create subtypes. Otherwise, you can just put it in a single attribute called designation, and then you can just store it in this professor table. Okay, so that is why the remark was made about, you know, supertypes and subtypes initially, which is basically when it is applicable or not here. Okay, so these entities must have attributes that are unique to them. Otherwise, you cannot create them. All right. So keeping that in mind, we cannot break down professor anymore. Maybe for staff, you can look into it. But for students, we can create two more. Or we can go specialization on students and do undergrad, let's call it UG, and then grad. Okay, because graduate students will have thesis options and stuff like that. Okay, so you can put that in this particular subtype, right? And you can create a specialization out of it. So now if you want to complete this, what is the participation? The participation is asking for, can a student be undergrad and grad, or can there be something else? So that is again a good question, right? You have to think about that. So just for the sake of simplicity, let us put it as complete right now. So that means a student has to be either an undergraduate or a graduate student. Okay. And then the next one is basically the cardinality. So that means, can an undergrad student be both undergrad and grad at the same time? No. Right? So then we will put disjoint, and then we will finish this, and then the discriminator is going to be, let's say, is a grad. Okay, something like this. So that kind of improves your design. Now remember, a note here. So now you get the idea, right? So that once you have generated your ERD, these will be some of the initial entities that you will have. So thereafter, what you will do, now you will look at the entities and you will go for a bottom-up sweep. Okay, so to find generalizations, whatever comes out of it, comes out of it. Okay, then you will do a top-down sweep for specialization for all the original entities. Remember, you don't have to revisit and reevaluate for the subtypes or for the supertypes that you create. You don't have to revisit the supertypes, but you have to revisit the subtypes. Okay, and that is how you basically apply EER. So a quick note here. In MySQL workbench, you won't have the notations of discrete slash overlap and then partial or complete. These are not present. Okay, and the reason behind that is Workbench, as you remember, we have talked about this. Workbench is going to convert the design directly into code. So these representations are essentially conceptual for our understanding. But in Workbench, this will be directly implemented as a 1:1 relationship. Okay, but conceptually, you have to remember what the differences are in the relationship or the association of subtypes and supertypes and how are they participating with each other. Okay, so basically, how it will translate into the Workbench environment is the fact that if it is partial, that is, if the participation is partial within Workbench, this will basically translate to so this will be like this. Okay, so this is what the participation will translate to. It will have a, so that means a staff must be an employee, but an employee may or may not be a staff. That is what this partial participation means. That is, any instance here can be more than the subtypes that has been specified. Okay, and for disjoint and overlap, it's also pretty simple. It's with the implementation of your foreign keys. So the foreign key will be either present or null. Okay, so there can be multiple instances of this. So you can combine the foreign key instances with the subtype discriminator in order to express the disjoint and overlap cardinality. Okay, but this is how it will look like in your Workbench environment. Okay, so for this side, you will have something like student, and then student will have a 1:1 relationship with grad. Okay, and then undergrad. Okay, and there will be 1:1 here, 1:1 here, 1:1 here, 1:1 here. Okay, and then you can do the subtype discrimination. So remember, when you go and you try to implement EERM, In MySQL Workbench, there is no representation for these notations. That is conceptual. Since the implementation is 1:1, you're still going to be using the notations of ERD in order to express the concepts of EERM. So that is why whenever you add a new diagram in MySQL Workbench, it always says EER diagram, but the notations does not have these disjoint overlap. So that is the clever part of it. Okay, so don't get confused or kind of lost that where are these symbols in the palette of MySQL Workbench. There isn't any. It's this only. Okay. So that basically wraps up the discussions of the first part of chapter 5 about enhanced entity relationship modeling. In the next part of this video for chapter 5, we will be discussing mostly conceptually about the different heuristics that are available to us to systematically select the primary keys, and then some different specific database scenarios, and we will talk about what kind of actions that we need to take as database designers in those kind of situations. Okay, so I'll see you all in the next video again. So until then, stay safe and take care.